Welcome to the Cannabis Growth, Manufacturing, and Testing Module, Section 5, Cannabis Testing. Cannabis is a bioaccumulator, meaning that any metals, pesticides, or toxins in the water or growth medium will be absorbed by the plant and could end up in the final cannabis product. In addition, the use of potentially dangerous extraction solvents could pose a threat to health if not properly and completely removed from the final product. Mold, fungus, or bacteria can easily grow on cannabis plant material if not handled and dried properly, which poses a health threat to consumers and could potentially trigger allergies and/or asthma. Even though trace amounts of some mold, fungus, or bacteria would not normally pose a threat to a healthy individual, extra care must be taken to ensure these are completely eradicated from cannabis medications to be used by patients who may be immunocompromised. Finally, the final potencies of the cannabinoids found in the product should be tested for accurate labeling to ensure patients and consumers know exactly what is in the products they are purchasing. Due to the federal illegal status of cannabis, neither the EPA nor the FDA have provided any guidance on how to regulate contaminants or what exposure levels can be considered safe. Most controlled cannabis programs require testing for cannabinoid potency, pesticides, residual solvents, heavy metals, mycotoxins, and microbiological contaminants. These tests are run through a variety of analytical testing processes, which can create significant cost to the dispensary company. However, these tests are deemed necessary for any well-regulated cannabis program. Although there are many minor cannabinoids and terpenoids that can be tested for in cannabis, most regulatory programs only require testing for THC and CBD potency. Although high-performance liquid chromatography is becoming the industry standard for cannabinoid potency measurements, there are currently no national industry-wide regulations or best practices for cannabinoid potency testing. This means potency results may vary widely between labs for the same cannabis product. Due diligence should be used to ensure potency testing is done at an independent laboratory using proper techniques to ensure accuracy and safety for patients and consumers. Pesticide residues have known toxicity to humans, which is increased in cannabis use due to the fact that the primary route of administration is inhalation, unlike the majority of other agricultural products. Up to 69.5% of pesticide residues remain in smoked cannabis. However, the Environmental Protection Agency will not register pesticides or set tolerance levels for use on cannabis due to its illegal federal status, claiming it has, quote, yet to receive any applications for pesticide use on marijuana, and therefore we have not evaluated the safety of any pesticide on marijuana, unquote. Additionally, the U.S. Department of Agriculture will not label any cannabis product as organic for the same reason. Illicit or negligent growers may use pesticides found in garden supply stores only approved for landscape plants or hydroponic fertilizers only intended for ornamental plants. In the year 2000, a study was published indicating a list of pesticides commonly used by cannabis growers and included several known harmful substances. Subsequently, the AHP published a list of pesticides most likely to be used on cannabis, which included 12 insecticides, 4 fungicides, and 3 plant growth regulators, all known to have potential harm to humans if consumed. Several sources exist for pesticides which should be safe for use on cannabis. Many growers stick to 25B pesticides, which are considered minimal risk and are exempted by the EPA. These include botanicals such as rosemary oil, as well as other substances such as potassium sorbate. The Organic Food Production Act of 1990 also has a national list, which includes botanical poisons, minerals, and biological control organisms that can be used for pest control. Pesticide testing of cannabis is challenging and costly because each pesticide must be tested for individually. Cannabis grow facilities are notoriously secretive about their pesticide practices, which often leaves regulators in the dark as to what they should be testing for in the first place. Although there is no federal regulation on residual solvents in cannabis products, most regulatory programs utilize the guidelines from the U.S. Pharmacopeal Convention Herbal Medicines Compendium, which outlines acceptable levels of residual solvents based on the solvent's toxicity potential. For example, ethanol is classified as a Class 1 solvent, the lowest risk, with a limit of 0.5% weight by weight in the final product. However, the hydrocarbon solvents are not included in these guidelines, as they are not typical solvents used in the processing of medicines. This is of great concern, given the known toxicity of these compounds, as well as the known difficulty of removing them from the final product when they are used. The current residue limits for hydrocarbons varies widely among states. California has a residue limit of 5,000 parts per million, Massachusetts a very strict limit of 12 parts per million, and Colorado lies in between with a limit of 1,000 parts per million. Clearly, additional regulation is needed when addressing residual limits of hydrocarbon solvents to ensure patient safety. Supercritical carbon dioxide evaporates into gas once the pressure is released from the extract, so there is no concern with any residual solvent remaining when using this extraction method. As mentioned, cannabis is a bioaccumulator, meaning it can potentially absorb heavy metals such as cadmium, mercury, lead, arsenic, and nickel from the soil, water, or pesticides that come in contact with the plant. Nickel is absorbed 10 times more efficiently in humans through the lungs than through the digestive system, which also plays a role in potential harm from heavy metals, given that inhalation is the most commonly used cannabis delivery method. It is important to note that most studies show metal accumulation in the roots, leaves, and stems of cannabis, not within the flowers and trichomes, meaning that the method of processing and extraction will have a large impact on the amount of potential heavy metal present in the finished product. The AHPA provides the following as guidance on maximum quantitative limits of heavy metals. Inorganic arsenic is limited to 10 micrograms per day, cadmium at 4.1 micrograms per day, lead 6 micrograms per day, and methylmercury 2 micrograms per day. Despite the fact that cannabis is known to accumulate metals and that certain metals pose a danger to consumers, some state regulations do not require heavy metal testing of cannabis at all. An additional and often overlooked source of heavy metal contamination could also be the handheld vaporizer devices commonly used with cannabis oil cartridges in both the legal and illicit markets. The metal heating coil, wires, and joints of the device may all release metal particles when heated. Additionally, the solder and other metal components of the vape cartridges themselves could potentially leach metals into the cannabis oil over time. Based upon a study evaluating the impact of vaporizer power levels on metal emissions, the authors extrapolated data to predict the inhalation from certain devices could exceed the chronic minimal risk levels for both manganese and nickel. Microbial contamination is an obvious health risk to consumers, particularly to immunocompromised patients. Cannabis plants can easily pick up molds or bacteria through the growing and harvesting process from the environment or from non-sanitary manufacturing practices. Outbreaks of hepatitis A and B, as well as salmonellosis, have all been reported. Due to the fact that most plant material is heated through combustion or vaporization before it is administered, it is a common misconception that any potential pathogens would be rendered inactive by this process. However, several pathogenic spores, such as those from Aspergillus, can withstand combustion and pose a serious risk to patients. Different routes of administration also complicate factors, as contaminants may be harmful when inhaled and harmless when ingested or applied topically. The American Herbal Products Association formulated a list of organizational standards for microbial limits in botanical products or extracts. You can plainly see the variance and lack of agreement between agencies when it comes to acceptable levels of microbial contamination. Additionally, the United States Pharmacopeia criteria for inhaled dosage forms is even stricter when it comes to the acceptable level of microbiological contaminants. In 2014, the American Herbal Pharmacopeia provided microbial and fungal limits claimed to be consistent with state, federal, and international regulations for botanical products in a revised monograph entitled Cannabis Inflorescence: Standards of Identity, Analysis, and Quality Control. These guidelines have become the gold standard for testing requirements by state regulatory bodies as well as within cannabis manufacturing and growing facilities. In summary, cannabis can be grown in a variety of environments, all of which have potential risks and benefits and should be assessed based upon the final use of the plant product. Harvesting cannabis must be done with care, as improper drying and storage can lead to the growth of contaminants which are undesirable and potentially dangerous to patients and consumers. Cannabis extracts can be produced through a wide variety of extraction methods. It is important to have a good understanding of how cannabis products are produced in order to assess the potential risks and benefits to patients and guide clinicians as to what to look for in terms of product testing. All consumable cannabis products should be tested for potency, microbial contamination, heavy metals, and pesticides to ensure there is no undue risk to patients or consumers. It is also important to familiarize yourself with the testing requirements, or lack thereof, within your state in order to have a clear understanding of the potential hidden contamination risk to patients or consumers. This concludes the Cannabis Growth, Manufacturing, and Testing Learning module. Thank you for joining us.